Hello, Professor Suyanto and everyone else who is watching. My name is Rifqi Fata with NRP 509-201-026. And here I will be presenting about my instrumentation system project assignment. So the instrument that I will be evaluating in this assignment is the instrumentation system of a primary reformer superheat steam burner, of a steam system that is used in an ammonia production unit. So superheat burner functions in generating superheated steam, elevated superheated steam, by burning it directly through the tube coil using the methane gas as its fuel. The steam that is generated by the steam system can be used as the supporting system for the utility of the plant, and among them, it can be used as the heat source for the heat exchanger. It can be used as the fluid that will be used to move the compressor and turbine to generate electricity, and it can also be used for instruments that uses the pneumatic system. In the context of oil and gas industry, superheated steam can also be used in several techniques of enhanced oil recovery, such as steam injection, and in sterilization as well as distillation process. So first of all, we'll be going over the process flow diagram of the steam system. Here we can see that the demineralized water from the OSBL will enter the deaerator before getting pumped by the high pressure boiler feed water pump into the steam generator, where it will be heated for the first time. The heated water will then continue onto the steam drum, where it will be separated between its phases of liquid and also steam. The steam will then move on onto the high pressure steam superheater, where it will be heated before entering the primary reformer, where it will be burned by the burner to produce high pressure, medium pressure, and also low pressure steam. This advanced superheated steam will then be distributed throughout the unit for any other sections of the unit that needs it. Next, we have the piping and instrumentation diagram, or the P&ID of the system. So this generally focuses on the HP steam superheater, and the main component is the primary reformer or the burner. And if you compare to the PFD, then it focuses on this section. So first of all, we can see that the steam from the steam drum will enter the HP steam superheater and will be heated by the process gas. After which it will generate a superheated steam that will be burned and processed in the primary reformer, generating a dry advanced steam. So here, the primary reformer is controlled and stabilized using 4 loops. So we have two pressure loops, which is loop 1018 and loop 1013, as well as 2 temperature loops, which is loop 1005 and loop 1020. So we'll be going over all of these loops and how it connects to the primary reformer. So first of all, we have the first temperature loop, which is loop 1005. So here, the dry superheated steam generated from the burner, the temperature data will be read by the temperature transmitter, and then it will convert it to an electrical signal that will be read by the temperature industrial controller. The temperature indicator controller will then decide what to do and continue the signal to temperature transducer, where it will then convert the electrical signal to a pneumatic signal, which will then control the opening of the temperature valve. The temperature valve will then allow fuel gas to enter. So how does this connect? Well, you see, the lower the temperature of the superheated steam that is read by the temperature transmitter, then it means that it needs more fuel. So the lower the temperature is, then the bigger the valve opening will be, so that more fuel gas can enter for the burning process. On top of that, we also have a pressure loop here, which is loop 1018. And this pressure loop, same as before, it will read the pressure data. The pressure transmitter will read the pressure data of the superheated steam generated by the primary reformer, which will then continue the signal to the PIC or pressure indicator controller, and then to the pressure transducer, and which it will then control the opening of the PV1018 valve. The PV1018 valve controls the process gas that is generated and used by the process gas that is used by the high pressure steam superheater. So if there is any leftover gas, it will then go through this valve, in which it will then be used for other processes. So the main output of the primary reformer is the high pressure steam, but not all of them are high pressure steam. some of them will instead go through this loop below. So some of the dry superheated steam generated by the burner will then go to the PV1013 valve. So this valve, the opening is controlled by the input from the 1013 loop pressure transmitter. After the superheated steam goes through, it will then meet a heat exchanger in which it will have its heat exchange to generate a medium pressure steam. As for the input of this medium pressure, as for the input of this heat exchanger, other than the high pressure steam generated by the burner, it also features steam from external. Now, this external steam, its entrance is controlled by the temperature valve of the 1020 loop. So the data of the medium pressure steam will then be used to control the temperature in the controller, which will then control the opening of the TV1020 valve, allowing the steam from external to enter and then contribute to the heat exchanger to generate the medium pressure steam. Now you might be wondering, what does these symbols mean? Like there's circles with a stripe in the middle of it, and there's also squares with a circle in the middle of it. What do they mean? What do the letters mean? What do the numbers below them mean? So we can see what do they mean in the following instrument and process symbol and identification tags table. So we can see that T here, you can see that P in the front stands for the unit. So the control variable. So here we have pressure for P, and for T, it's temperature. As for the T in the back, it stands for transmitter. So PT would stand for pressure transmitter, and TT would stand for temperature transmitter. Likewise, PIC stands for pressure integration controller, and TY stands for temperature transducer. As for the number below them, it dictates the loop number. So for example, since this is taken from the 1018 loop, then it showcases that this instrument is part of that 1018 loop. The shape itself dictates the additional information. So if it looks like a circle with a stripe going through the middle, that means it's a discrete instrument that is located in or in front of the main console or panel. But if it has a square surrounding it, then that means that it is a primary instrument or a part of a DCS that is also located in or in front of the main control panel. Other than these instruments, we also have the valves, which is divided into pressure valve and temperature valve, both of which are generic valves with actuators. There's also a pneumatic signals, which is generated by the temperature transducer, and also electrical signal. So we can see here that the data will be read by temperature transmitter and then will be converted into an electrical signal. And then this electrical signal will then be converted again into a pneumatic signal by the temperature transducer. We also have the thick line here, which showcases the main piping line that is from the input to the output, so from steam to high pressure and medium pressure steam, as well as the impulse piping line, which describes the connection between the loops that surrounds the primary former. And lastly, we also have the shell and tube heat exchanger, which will heat the high pressure steam into medium pressure steam. Next up, we have the loop diagram. So here we can see the information of which loop that is used. So this loop diagram only focuses on one loop featured in the P&ID. So here we can see that it focuses on the high pressure steam temperature loop, or from the number we can see that it focuses on loop 1005. In other words, this loop here, which reads the temperature data from the high pressure steam, which will then control the opening of the temperature valve 1005. So here we can see that it starts with the temperature transmitter of 1005, in which it will read the data of temperatures scaling from 0 to 1500 Fahrenheit. We can also see an up arrow here, which signifies that the output is parallel or proportional to the input. So the bigger the input is, the higher also the output is. The colors here signify the color of the cables, and this signifies the name of the cable. So since this cable connects the temperature transmitter with the temperature indicator controller, then the name of the cable is cable TT1005. So on the left-hand side, we have the process area. In the middle, we have the field panel. And on the right-hand side, we have the control room panel. So first of all, the signal that is read by the temperature transmitter will then be delivered through this block here, which is TB15. which will then continue on until it reaches the temperature indicator controller. However, you can see that for the temperature indicator controller, the arrow is facing down. This means that a reverse action is occurring. What it basically means is that the output is inversely proportional to the input. So in other words, the smaller the input is, the bigger the output will be, and vice versa. The reason as to why this happens is because the opening of the valve, the TV valve, is dictated by the temperature of the superheated steam. So if the steam's temperature is too low, then the valve will open because it will open to make way for new fuel to enter. So for example, here, you can see that if the temperature of the superheated steam is high enough, then the valve doesn't need to open. They don't need an additional fuel gas to burn steam inside the primary reformer. So moving on from the TIC, we can see that the signal will continue on moving onto the TY or transducer, in which it will be then converted into a pneumatic signal to control the opening of the valve. And we can see the top of the signal here. As for the ES120 VAC, it stands for the emergency switch, and AS stands for the supply, the main supply. There's also additional data in the bottom of the diagram that signifies the tag number, description, input, output, as well as additional notes about the specific part of the instrument featured in the loop diagram. So for example, for TIC 105, so for the instrument with the tag number TIC 105, it is a temperature controller for the 1005 loop or the HP steam temperature loop. The input is a 4 to 20 milliampere electrical signal from temperature transmitter. However, since there's a reverse action, it will then convert the signal inversely. So the smaller its input is, the larger the output will be. This output will then be moved on to the temperature transducer. And last but not least, we have the functional diagram, which basically describes generally how the loop works. So since we have two kinds of loops here, which is the pressure and temperature loop, for example, we can here, so here we have the pressure transmitter on the left and temperature transmitter loop on the right. So for the functional diagram of the pressure transmitter, we can see that the data read by the pressure transmitter will then be processed by the P&ID, in which it will then control the opening of the pressure control valve. Likewise, for the temperature transmitter, the data that is read by the temperature transmitter will then be processed by the PID to control the opening of the temperature control valve. I think that's all for my presentation. I hope you can understand. I hope it can be helpful, and I hope it can also add knowledge to you. Thank you very much for your attention, and wassalamualaikum warahmatullahi wabarakatuh.